Robot operating system, a very important framework that most of the companies even write as a job requirement in their job descriptions, and that big framework ROS has to be brought onto the microcontroller, and in between this is Micro-Ros, on which today this video is all about, bringing that Micro-Ros into the small robot that we just produced. Let's go through the process of driving the robot through our laptop over Wi-Fi communication, ROS framework, and driving the direction signals on its OLED. For MicroRos development, we are going to be first starting with MicroRos PlatformIO because it is really simple and we have worked a little bit with this on our different projects. The other way that is documented is complex for starters, but it provides you more features. Let's start with basic one, MicroRos PlatformIO. So here we are going to go through its documentation and follow the steps. Then we are going to integrate it into our project. Let's first perform the sudo apt install python pip, which you might already have. I already have it. Then it says you can add it into your project and installation of the PlatformIO, but we are going to be using VS Code, and here I already have installed PlatformIO. Let's click upon it, create a new project, and here new project, we are going to be naming it MicroRos bot. Let's select the board. In our case I have esp32 dev kit v1. Framework is going to be Arduino. I am going to be putting it inside of my robotism workspace in the source folder and finish. You have to only open the folder that you have, so PlatformIO gets initialized easily. It tells us about esp32 and its dev kit settings. First of all, we have PlatformIO. Then inside of that we have main CPP file that is going to be containing the main code. Inside of that, with MicroRos RCL CPP, we have 4 points to look into for creating a node. MicroRos provides us the interface using RCLC, which is using ROS client library C, and in C we have an executor, support, and allocator. These are the three main things that provides us the capability of having communication in between nodes on a ROS2 framework through ESP32 embedded hardware to our laptop. Regarding the libraries, we are going to be defining it and pressing Ctrl save. Whenever we add something in platform ini file and press Ctrl save, it automatically starts initializing that thing, which is downloading it, performing different tasks, whatever it is defined. So it is now obtaining the repository and it will be executing the commands the way it is designed. Let's look into its documentation further. It says that ROS2 distributions that you have to define in your PlatformIO settings is humble, iron, and rolling. By default it's iron, but in our scenario we have humble, so we are going to select this and also define it here and make it humble, so it can easily communicate. The thing that just appeared was call can build here. This call can build came because of the call can build that is running on the backend while it is installing this package. And interestingly, we don't have to do anything regarding the build process or anything. We just put this line and saved it. Now let's again look into it. So there are serial communication process that we have, and there is an Wi-Fi based approach as well. We will first run the serial based. Let's go into the basic examples here. Example MicroRos publisher and source. It also have platform ini file. In ini file you can see MicroRos transport is serial and lib depends. This is already written. Let's take a look into the main CPP file that is going to be compiled and placed. We are going to copy it and put it into our main CPP file here. Let's save it. We will compile it once this is completed. So where were we? In the documentation, where is installed, then next thing was serial communication. We have to set the communication transport to be serial in the platform ini file. So I am going to copy this, and in my ini file, which is here, let's put it here, which tells the system that now it is communicating serially. If we go here, the reason I am showing all of this documentation and copy pasting is just to make sure that I'm not taking anything from my knowledge. It's all documented and you can extract it as well. Currently we are using serial. We can go with Wi-Fi as well. Now let's talk about agents. Now we can see here, this is again another call can build, and it says project has been successfully updated. I will press Ctrl S and it is going to save all the settings. This serial communication is going to be set. MicroRos Humble is going to be also set. Let's try to compile it because we have made the changes in the main file. Compile this. It has successfully compiled it. Let's upload this. I have already connected the board and we can see it is uploading our simple example, which is nothing else than a simple publisher, I guess, onto our esp32. Now we had a main file. In that we have MicroRos RCLC, executor support allocator. Now to make our laptop ROS2 system communicate with an embedded device, we have to introduce an agent. Agent is going to have bidirectional communication, which means that we can publish and subscribe from an agent, and publish and subscription can be done on the laptop for the same thread. As we will be driving using command velocity, which is going to be published by our system and subscribed by our agent. We can also publish data from agent in the next projects we will see, but the agent is the main thing that we need to run for the communication between our embedded system and the actual laptop ROS2. Once the code is uploaded in ROS2 MicroRos interface, we have something for communication between our system and our microcontroller in agent. Agent is a very interesting thing that we have to look into for the communication, but there are some cons for agent as well, as it removes the decentralization of ROS2 system, but the developers have built it in such a manner. Let's go through this MicroRos tutorial. First, MicroRos application in FreeRTOS, where all of the commands for installation of the agent as well as MicroRos firmware installation is listed, and you need to know that it does exist here. We are going to follow the steps and make dir MicroRos workspace. Let's go into MicroRos workspace. It says clone a repository. Press enter, and till that point we are going to look into the repository. What does it contains? MicroRos setup. A ROS2 package is an entry point for building MicroRos apps for embedded platforms. Supported platforms are FreeRTOS, Zephyr, Embed, Linux and Android as well. And in our scenario we are only interested in esp32. I am unable to find it here. Let's search it. Okay, it is here, Espressif esp32, and there is a MicroRos documentation for it, and things become really easy as Espressif is main company which provides IDE for development of a lot of applications for esp32. Now coming to our interest, that was MicroRos. We have cloned this repository into source MicroRos setup, but it says first perform this and install from sources. Till that point we are going to add our MicroRos workspace source and this package to look into its files. What does it contains actually? Back on it, things are working. They are updating and installing things. We have to make sure that I have already copied the next command, which is ignore source and install all the dependencies. Let's run this, and it says all dependencies are installed. Let's look into the next part, which is simple call can build. I have already done that. So we'll open up terminal, call can build it. It is building this package. Package has been built. Let's look at the package. MicroRos setup. So in MicroRos setup we have scripts, build agent, build firmware, configure firmware, and a lot of bash files that perform a lot of functions. Let's go into the documentation again and just go through simple steps. It might be a lot confusing for you because of the complexity that we are getting into, but once we have gone through one single iteration, we will then dumb down everything and understand. So first it says create a firmware workspace, and that is done through this command, which is firmware sh till this point and FreeRTOS, and then this development board. In our case it is going to be FreeRTOS esp32. Then it says it generates these two things and RTOS application. Configure the firmware. Then next step of creating firmware is configure the name of the app and the other options that are serial, UDP, anything. We will go through these commands at the end because it is a different process for building apps using RTOS. We are currently working with PlatformIO. So at this point, let's directly skip this firmware process and directly move towards our MicroRos agent. which is this part, because we have already uploaded through PlatformIO and all of these steps are done. Let's look into this. MicroRos agent, create an agent. Let's first source our workspace and we are going to try to run MicroRos agent. With the command, an agent files have been cloned and it says dependencies are done. Let's copy this command, which is build agent, and it starts some build process, which is basic call can build process. And we can see the package has been built. It took surely some time, but it is now built. It's time to run our MicroRos app. So let's copy this command. Apparently it just seems to be copy pasting of our commands, but I will explain everything once we make it working. So my device is connected to dev TTY USB 0 as it is connected there. If yours is not, then you can simply list dev TTY USB list all. It will tell you all of the devices that are connected. So press enter here and it starts the agent. For my microcontroller to work with it, I have to restart my microcontroller. I can plug it off and plug it again, or I can just press the reset button on the ESP32. Now I've done that and we can see some lines came up and it said session is established, participant created, topic created, publisher created, data write. Some sort of things are happening. Let's clear these. ROS2 topic list. And this example MicroRos PlatformIO node publisher is here. Let's perform ROS2 topic echo. What does it publishes? It is a counter that is publishing things. So in a nutshell, our whole MicroRos making ESP32 communicate serially right now has been completed. Let's now go into it once again. First of all, what we did, in the main file we brought the code and we uploaded it. Let's press upload it again. Let's make some changes here. The data is going to be continuously making a negative value. Timer callback function. Let's now upload it. It might say that device is unavailable because agent is communicating with it. So I'll stop it here so it can communicate now. It is uploading the code. Once the code is uploaded, our whole setup is done for the MicroRos agent side. We will just say build agent in the workspace and we can say start the MicroRos agent serial communication and restart our ESP32. And we can see simple connection has been established. This time it is going to be giving us a negative value. We will go through the main code that is written here because we have to be driving the robot, but just understand the basic process here, which is simply uploading the code from the main, then running the agent directly and restarting your ESP32. These are the 3 steps that you have to be doing whenever you want to make the ESP32 communicate with ROS2 system on your laptop. It took me a series of steps that I have encapsulated in lecture series on robotism to bring out libraries and divide all of the ROS Wi-Fi communication into a library that can be easily included into the main file, and we can just say initialize the motor setup, initialize the ROS communication, subscriber or publisher define, executor start, and start receiving the messages. Everything is reduced to very simple function calls. In ROS communication, all of the functionality required and the function definition required are distributed into different functions. ROS communication class initializes the Wi-Fi access, and then we have ROS communication executor starts that describes the publishers or nodes types, publisher or subscriber. Then we call the subscription actual definition and wait for the command velocity callback. It is also incorporating the OLED display and motor control to drive the robot through this laptop using command velocity topic and displaying the arrows as we did in the previous project. So it takes a lot of steps that are explained in detail on robotism. You can check out the lecture series. I will be providing you the code. The main objective was to simply enable our ESP32 based MicroRos development over Wi-Fi. ROS is an open source software, so it opens up a lot of doors for us that we can integrate this package, this robotics implementation into a robot once we have MicroRos setup. We have serial and Wi-Fi interfaces depending upon our requirement. And in the future, I am planning to integrate camera through ESP32 onto ROS ecosystem through MicroRos. So it is going to be really interesting. We can add a lot of things into a robot, as our basic robot is now ROS enabled.